Hi, my name is Brittany Marr, and for my sports science final, I have chosen the sport basketball. Most of my examples were not filmed inside a gym because we are not allowed gym access for most of the time, and so they had to be done in hallways and other places. First, I have chosen velocity, and my example is a fast break running down the court, and that actually is actual game footage from this evening.
Firstly, we have velocity, and the formula for velocity is distance divided by time. The distance is 10 meters, and the time is 2.02 seconds. So our total velocity is 4.95 meters per second.
Next, I have chosen acceleration, and this was in the form of conditioning during practice, but this had to be filmed in a hallway before our game.
Acceleration, and my original formula is incorrect. It is also distance divided by time. And our distance is 15 meters, and our time, which we have to take the average velocity times 2, would be 2.73 times 2, which equals 5.46. So our entire acceleration is 2.75 meters per second squared.
For force, I picked running down the court on a fast break.
My formula for force is acceleration times mass, but we don't know the acceleration, but we do know my mass is 60 kilograms. To find the acceleration, we do distance divided by time, and our distance is 26 meters, and then our time is 5.76 times 2, which equals 11.52. So our acceleration is 2.26 meters per second squared. We put that back into the force formula, and we get 135.6 newtons.
For our conditioning during basketball season, we run laps around our school, and our school has a lot of stairs, so my power is going up the stairs.
Calculations to find power, but to start with, we have work divided by time, but we don't know work, so we go to the work formula and we don't know the force, and then we go to the force formula, but we don't know the acceleration. So we get to the acceleration and we can figure out acceleration with our numbers. And so we have a distance of 2.25 meters and a time of 3.01 seconds. So our acceleration is 0.74 meters per second. So then we plug the acceleration into the force formula, which would end up being 44.4 newtons. And then we put that into the work formula, and that ends up making 99.9 joules. And then we put it finally back into the power formula, which is work divided by time. And so we would get 33.19 watts for power.
And finally, I've chosen body levers as strength training during basketball season.
I do. Finally, for body lovers, we have to figure out the mechanical advantage, and it's effort arm divided by resistance arm. My effort arm is 1.5, and my resistance arm is 14. So in total, our mechanical advantage is 0.107.